So as from the childhood we have learned about gravitation. We have known something about gravitation. Okay. So gravitation has been a thing of interest. We first came across gravitation by the Newton's Isaac law. Is- uh, Newton's law of gravitation. Okay, but before that also there was something known about this gravitation. So what is gravitation? Gravitation, it is the force of attraction. So gravitation, it is the force of attraction. Okay. As we know that between two bodies there can be a force of attraction or there can be a force of repulsion. Okay. Yes. Is there any issue?
No, sir.
So force of attraction between any two bodies. Force of attraction between any two bodies in universe. So this is the force of gravitation between any two bodies in the universe. Two bodies in universe. So any bodies in the universe, they attract each other with a force. Okay. So gravitation is a force which is always attractive in nature. It can never be repulsive in nature. Okay. So gravitational force, it can never be repulsive. It is always attractive. It always attracts two bodies. Okay. So gravitational force, it is the force which is always attractive in nature. It always attracts two bodies. So if attracts every two bodies, that means it is the force which exists between the sun and the earth. It is the force that exists between the earth and the moon. Okay. Not only the celestial bodies, even all the bodies on the earth, they are attracted towards each other with the force of gravitation. Okay. So what is gravitation? This is the force of attraction between any two bodies in the universe. Okay. Force of attraction between any two bodies in the universe, that is called as gravitation. So to understand this, what is gravitation, there was different explanation, but this was Isaac Newton who studied in great depth about the gravitation. Okay. So what did Newton explains his universal law of gravitation? So as per the Newton's universal law of gravitation, it means that as per the Newton's law of universal law of gravitation, it means that there is a force of attraction between two bodies. Okay, like if you see the electrostatic forces, or Smith,
Yes, sir.
okay, the electrostatic forces between any two objects, can they be repulsive in nature? Can there be a force of repulsion?
No, sir. No.
No. Okay. So are you getting my question or just saying yes and no?
Sir, can I say once?
See, we have stated that the force of gravitation, it is the force which is always attractive in nature. Okay, or the force of attraction between any two bodies in the universe is the gravitational force, right? So about the electrostatic forces, when I say about the electrostatic forces, so electrostatic forces are the forces between two charges. Okay. Just like the gravitational force, you also have heard about the electrostatic forces. You have also heard about, apart from electrostatic forces, you have studied about some magnetic forces. Okay. So these electrostatic forces, magnetic forces, are these attractive in nature or they are repulsive also?
They are both attractive and repulsive.
Okay. So both of them, these electrostatic forces and magnetic forces, they can be attractive as well as repulsive in nature. Attractive and repulsive, they are both. Okay. Like we have heard that the similar charges they repel each other and opposite charges attract each other. Siddharth, Siddharth, are you there? Siddharth and Siddhisri. Siddhisri, turn on your camera. Siddharth, you are supposed to keep your camera on every time.
He just went to washroom, sir. He will be back in 1 minute.
Okay, ma'am. Okay. So, attractive and repulsive forces. So, what are the, as we observe that the electrostatic forces and the magnetic forces, they can be both attractive and repulsive in nature. But the, okay. But the gravitational forces, they are the forces which are always attractive. Every two objects in the universe will always attract each other. They will never repel each other because of the gravitational forces. Okay. If the force is the gravitational force, they will always be attractive in nature. There are no two poles like the electrostatic forces and the magnetic forces. There are no two types. Okay. So it is the gravitational force which is holding the solar system. It is the gravitational force which is holding our galaxy together. Okay. There are many solar systems. So the different solar systems which exist, all the solar system, they are held together by the force of gravitation of the corresponding stars. Like our solar system is held by the gravitational force of the sun. The sun is holding all the planets and everything with the force of gravitation. So not only the celestial bodies, even on the earth, like objects, we are also objects. The various objects that we see, they are also things. They also have masses. So they also have a force of attraction between them. Okay. So a common question arises over here that if there is a force of attraction between all the objects, if there is a force of attraction between, if it is correct that there is a force of gravitation between all the objects, so all the objects attract each other with some force, right? So why over here we do not find any attraction on the objects on the earth? Why don't two people's body attract each other? Just like we see that a moon is held together with the earth with the force of gravitation. So why don't two objects come together like this? On the earth also we observe that if you throw a stone in the upward direction, so the stone returns back, right? This we have
Uh,
observed that if, yes.
because the Earth's gravitational pull is more than our gravitational pull.
So I don't think that there should be any difference. Earth is attracting like this. See, all the objects on the earth, if you have your earth, all the objects on the earth, they are being attracted. So let's see if you have our earth, so all the objects on the earth, they are attracted by the earth's gravitational forces. So here, even a small object, if you have, you throw it away from the earth, so it will get attracted and it will remain bound to earth. Even if you throw it upward, it will return back to the surface of the earth. Okay. So in this case, we observe that the yes, the ball is being attracted towards the earth. The fruits of the tree, they are attracted towards the earth. Okay. Therefore, when the branch is broken, the branch falls down. That is because the branch is being attracted towards the earth. Okay. So why don't we see why if we say that the gravitational force it exists between all the objects in the universe. So if you have two objects over here, so why don't these two objects attract each other? Okay. So the reason we will see in the universal law of gravitation, Harini and Siddhisri. Siddhisri, is there any problem? Siddhisri, is there any problem? Turn on your camera, Siddhisri. Harini, turn on your camera.
So 1 second, sir. I'm just setting my laptop.
Okay. Okay, so these two objects we observe over here that these two objects they have a force of attraction between them, but still they do not attract each other. As per the statement of the gravitation law, gravitation they should also have a force of attraction. Okay, so for this we see the universal law of gravitation which was proposed by Isaac Newton. So the universal law of gravitation. So here, what was the universal law of gravitation? It states that all objects in the universe they attract each other. As per the universal law of gravitation, all objects in the universe attract each other with a force which is directly proportional to the product of their masses and inversely proportional of their masses and inversely proportional to the square of distance between them. So this is the statement of the universal law of gravitation that all objects in the universe they attract each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay. So how do we interpret this? Let's interpret this. The universal law of gravitation states that the force of attraction between two objects uh, is directly proportional to the product of their masses. So here one thing is that any object which has a mass, okay, so any object which has a mass will have a so to the product of their masses and inversely proportional to the square of distance between them. So that means any object which has a mass, it will have a gravitational force between them. Okay. And since all the matter objects they have mass, all the matter objects they have mass, so therefore there will be a force of attraction between them. Okay. So for this we consider here two objects. Let's have this object A and let us have here another object. So these are two objects which are separated by some distance r apart. So these two objects, they are separated by a distance r apart, having a mass m1 and mass m2. So they are having their different masses. This first object has a mass m1, the second object has the mass m2, and they are separated by some distance. So as per the universal law of gravitation, the force of attraction between them will be directly proportional to the product of their masses and inversely proportional to the square of distance between them. So here force between them, they will be attracted towards each other. That means this mass m1, it will be attracted towards m2. That means this mass m1, it will tend to move towards m2. It will experience a force towards m2 like this. So who is experiencing a force? M1 or M2?
M1 is experiencing the force.
M1 is experiencing a force. Okay. So here M1 is experiencing a force towards M2. Okay. Now, why it is experiencing? Because it has a mass. As per the Newton's law, all objects in the universe attract each other with a force which is directly proportional to the product of their masses. So the force between them will be directly proportional to the product of the masses, and it will be inversely proportional to square of distance between them. So M1 will get attracted towards M2, and M2 also get attracted towards M1. Okay. So M2 will tend to move towards M1. So both the masses, this M2 will also experience a force towards M1. So this M1 is tending to move towards M2. M2 will tend to move towards M1. So are you getting this? That both the masses, they will experience a force of attraction. Both the masses will experience a force of attraction. Aman,
So,
pay attention to the
basically
class.
gravity is just G then M1 by M1 into M2 by R squared. That's it.
Just understand what is being explained, right? We will get to those formulas, we will get to everything. Okay. What I am trying to say here, that understand that M1 is getting attracted towards M2, and M2 is experiencing a force towards M2, M1. Okay. So does it apply the Newton's third law of motion?
Yes, sir.
Okay, so here we observe that the Newton's third law of motion is applicable over here. That is, the force between these two masses will be directly proportional to the product of their masses. Force will be directly proportional to the product of the masses, that is M1 into M2, and it will be inversely proportional to the square of distance. So force will be inversely proportional to the square of distance. What it means, you will understand it again, that M1, force is directly proportional to M1 into M2. It is inversely proportional to the square of the distance between them. And also here we follow the Newton's third law of motion. That is, the two objects, they will experience an equal and opposite force. So M1 will experience a force of M1 into M2 upon R square. M2 will also experience the same force, but in opposite directions. Like M1 is being attracted towards right and M2 is being attracted towards the left. Okay. So let's see here if you are able to solve. Suppose I have two masses. I have two masses M1 and M2, and they are separated by some distance R. Okay. Mass M1, here you have mass M2. So M1 and M2, they are separated by some distance R. Now assume that the force between them is equal to F. Okay, the force between them is F. So now, what will be the force between them? If your at M1 becomes double and M2 also becomes double. If this mass is your 2 times of M1 and this mass is 2 times of M2. So what
Then
will be
it
the
will
new?
be R squared, sir.
Yeah, the distance is the same. So what can you say about the force that will be there between them? Harini, what will be the force between them?
So 1 by R square.
Or Smith, what will be the force between them?
One by R
Neha,
squared.
yeah,
1 by R squared.
1 by R squared. Neha, what can be the force between them? See, I want the force in terms of F. Okay. Here, the two masses M1
Yeah.
and M2.
So then gravitational constant into mass 1 into mass 2 by R square.
So that is why I'm telling everyone to pay attention here. Okay. Whatever you know, just keep it aside for a minute and think what is being taught. See, these are the two masses. One is mass m1, the other is mass m2. They are separated by some distance r. And let us say when they are separated by some distance r, so they are experiencing a force equal to F. This is the force between them. Okay. Now here I have a mass of 2m1 and I have a mass of 2m2 and they are also separated by the distance r. So what will be the new force between them?
2 into 1 by r square.
How much?
2 into 1 by r square.
No. See here, the force is directly proportional to the product of masses. Okay. So if you multiply these two masses, earlier the force was proportional to m1 into m2, right? So this F was m1 into m2, which was coming to be F. Now if you take the masses as F to be 2 times of m1 into m2 times of m2. Okay. So you will get your force to be 4 times m1 into m2. Okay. So m1 into m2, that means your new force will now become 4 times. If suppose here the force was 10 Newton and now the masses have been doubled, so the new force will be, how many Newton will be the new force there? Prince, how much will be the new force? See, this
Sir,
is something you have not studied in your class. Okay. So
sir,
this is
can I
something, yes,
start?
yes,
Sir,
that.
it will remain the same.
No, it will not remain the same. It will be 40 Newton. It will become 4 times. Here we observe that the product now has become 4 times. So therefore force will also become 4 times. It will become 40 Newton. Okay. So that is why I'm saying understand everything. This is not what you have studied in the class. We are getting you to a higher level. Okay. Understand the basics and then you can apply your knowledge.
Sir, I have a doubt.
Yes.
So if we write this in the form of an equation, so 4 equals to, F equals to 4 into m1 into m2 by r square, right? So if we take the 4 to the other side, it's going to be f by 4, right?
Okay. Okay. Let me tell you the complete story behind it. Okay.
Okay.
What do you mean by the direct proportionality? When we say directly proportional, so what does it mean? Directly proportional. Directly proportional means if one of the quantity will increase, the other quantity will also increase by the same factor. Okay. So such a relationship is called as the directly proportional relationship. For example, in your everyday life, what we observe, let's say driving your car. So driving your car, the relationship between speed and distance is a directly proportional. If you drive at a faster speed, you will be able to cover more distance. So they are directly proportional to each other. Okay. I will tell the same story in other terms. Like now, what will be the new force if I make the masses to be, let's say, if I make the first mass to be 3 times of m1 and the second mass as 3 times of m2. What will be the force between them? This will be 3m1, this will be 3m2. So the new force will be proportional to the product of the masses and it will be 9 times of m1 into m2. Okay, so your force will become 9 times. There will be a change of force which will be 9 times the product. So are you able to figure it out what I mean? That the force is directly proportional to the product of the masses.
Yes, sir.
Okay. Now, if we observe the inverse proportionality, so let's see the inverse proportionality something like this. Inverse proportionality means if we have a mass m1, another mass m2. See, I think in everyone's school this chapter has been taught.
Yes, sir.
Yes, everyone has learned this chapter. Abhinav?
Yes, sir.
Okay, but have you learned it this way?
No, sir.
No? So
This
that is
kind
the
of.
yeah. So just pay attention. This is now again, this is mass your M1, this is mass M2. They are separated by a distance R. Okay.
Sir,
So yes,
they did teach us, but then they told it like in a different way, kind of.
yeah. So in a different way, you are coming. You if you get this F proportional to M1 by M1 into M2 over R square, right?
Yes, sir.
And once you remove the proportionality, so you have force equals G times of M1 into M2 over R squared. This is what you have learned.
Yes, sir.
Okay. So keep this aside for a moment. Just understand the proportionality. First, we are understanding the proportionality and then we will come to this. Okay. So here, the force between the two masses is inversely proportional to the square of distance. Now here the distance is R. If I make the distance to be 2R, if the same two masses M1 and M2, now they are separated by a distance of 2R. So what will be the force between them? Now the distance is 2R. Earlier the force was F. So what will be the new force between them?
2r whole square.
Okay, anyone?
So 1 by 2r whole square.
Okay, force will be proportional to 1 over 2R whole squared. That means you will have force proportional to 1 over 4R squared. That means your new force will becomes 1 over 4 times the older one. If here they were experiencing a force of 10 Newton, so in this case, they will experience a force of 10 by 4. That's 2.5 Newton. Right? Chavan Kaushik, Aman.
Yes, sir.
Okay. So are you able to figure out, understand?
Yes, sir.
Okay. Now, what will be the force if the distance between them is reduced to 1 over 2? If the distance is reduced to half? Neha, what will be the force if the distance between them is reduced to half?
One by four R square.
Okay. It will be, you have here 1 over
Second.
R by 2 whole squared. Okay. So force will be proportional to 1 over R by 2 whole squared. And this will be, force will be proportional to 1 over R
4
squared
by
over
r
4.
square.
Okay. So this will become 4 by R squared.
Yes, sir.
Okay. So your force will become 4 times. So force between two masses, it depends on the product of the masses and it depends on the square of the distance. If you are decreasing the distance, force will increase. And if you are increasing the distance, force will increase. uh, okay. Then similar thing happens with the masses. Okay. Now let's come back to the Newton's law of gravitation and do the way you now think. The way you have studied this. So now we are going that way that the force between the two masses is directly proportional to the product of masses. See now what you have studied here. You have studied that these are the two masses. Okay. And they are separated by some distance r. These two masses M1 and M2, they are separated by the distance R. So the force between them will be equal to proportional to product of masses M1 into M2. It will be inversely proportional to the square of distance between them. If you combine the factors, so you get force proportional to M1 into M2 over R squared. if you remove the proportionality, so there is a constant force equals a constant G multiply m1 into m2 over r squared. Right? Now the value of the universal gravitational constant, that is capital G, it is determined by taking the masses to be 1 kilogram and 1 kilogram and finding out the forces between them. Okay. So here, this is what, from here we obtain that capital G, this capital G, it is called as the universal gravitational constant. It is a universal gravitational constant, and the value of this capital G is 6.7 into 10 to the power minus 11 Newton meter square per kilogram squared. This is the value of the universal gravitational constant. This G is the universal gravitational constant. That means the value of G is applicable everywhere in the universe. Okay. Everywhere in the universe, this value of universal gravitational constant will remain the same. It does not change. Okay, understood this much?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Sir, what's the value of small g then? Isn't it like 9.98?
We have
Small
not,
g.
up to now, we have not studied about the small g. Okay, when
But
we
can you
come, we'll
just tell
discuss
me
about
its value once?
its value on the surface of the earth is 9.8. Okay, on the surface of the earth, it is 9.8. Okay, so the force between two objects will be directly proportional to product of masses, and here we observe the universal gravitational constant. Its value was 6.7 into 10 to the power minus 11 Newton meter squared per kilogram. Okay, now here, can you try to just solve a small question? Okay, find the force of gravitation. Okay, I'm giving a question, just write down. Find the force of gravitation between two objects of mass 2 kilogram and 50 kilogram separated by a distance of 1 meter. So not 1 meter, separated by a distance of distance of 2 centimeters. Okay. So try solving this question. So solve this. Everyone will solve this. Find the force of gravitation between two objects of mass 2 kilogram and 50 kilogram separated by a distance of 2 centimeter. Okay, Siddharth, have you got the answer?
No, sir.
No. Okay. Chavan Kaushik, are you calculating?
Yes, sir. I am doing it right now.
Okay.
Sir,
Yes.
you're done now. Is it 3.3 times 10 to the power negative 9 Newton?
Okay, just keep your answer and send your answer in the chat section. Send direct message to me in the chat section.
Sir, I rounded it up further.
Yeah. Send your answers in chat. Neha,
Sir,
what is the answer you have got?
I'm still doing it, sir.
Okay. Rikshit,
Sir, I'm also still doing it.
okay, so turn on your camera. Why your camera is off? Please.
Sir, today I can't on my camera, sir. It's showing some issues.
Okay.
Sir, is it 1.6 into 10 to the power of 4?
Send your answer in the chat. And just after 1 more minute, I will solve this over here for everyone. So 2 people have solved, 3 people have given me answers. We will check whose answer is correct. See, the problem which we find over here, student find problem in calculation. Okay, the calculations seem to be very big. Even
So I
this is a
forgot
small.
to convert centimeters to meters.
Hmm. Do it, convert it, and then obtain. Okay, see. See here, everyone. Those who have sent the answer, well, very good. We'll check if you're correct. Just let see here. So we apply the formula of F, that is the force, will be equals to G times of M1 M2 over R squared. So the value of G we put as 6.7 into 10 to the power minus 11 multiply M1, which is 2 kilogram, multiply M2, which is 50 kilogram, divided over R squared. The value of R is 2 centimeter. We convert this R 2 centimeter to meter, and this will be 2 into 10 to the power minus 2 meter. So this is how you perform the conversion. Do not write, if you are converting 2 centimeter to 2 meter, do not write it as 0.02. Once you enter into the decimal, the chances of you getting the wrong calculations and wrong answer increase. You are most probable to getting wrong answers. Okay, now see here, everyone, how to solve these calculations. The calculations seem to quite tough, but they are very easy. First of all, open up all the brackets. Here you have, and take all the exponents to one side. Like here we take 6.7, and this 2 and 50 which to be multiplied over here. So 2 into 50, and exponent we are separating, which is 10 to the power minus 11. This we are separating at the end. Then from the denominator, if we make the square, this square of 2 will be 4, multiply 10 to the power, it will be minus 4.
So why are we taking 10 to the power minus 2 over here?
2 centimeter converted to meter will be 2 into 10 to the power minus 2.
So how is it minus 2?
How it is minus 2? Okay. So 1 centimeter is equals to 1 over 100 meter. Right?
Yeah.
Okay. And 1 over 100 can be written as 10 to the power minus 2.
Oh, okay.
So you got it. Anyone had the
Then,
same doubt?
but then we're already writing it down, right? So we have to remove the sign.
Yeah.
Wait, sir, so was my answer correct?
Just we are checking it out. Wait. Now take all the exponents. Here you have 6.7 multiply 50 times 2 is 100 divided over 4. And here you have 10 to the power minus 11 plus 4. And minus 11 plus 4 is minus 7. Okay, if we take this minus 10 to the power minus 4 in the numerator, we take this 10 to the power minus 4 in the numerator, it becomes plus 4. So minus 11 plus 4, it becomes minus 7. Okay, now we can easily divide this 6.7 divided by 4.
So, and the gravitational constant is 6.67, right?
Yeah, it's 6.67, but if we round it off, we get 6.7. Okay, this is 6.67, but if you round it off, if you round it 7 over here, so you get 6.67, 6.7, right?
Yes, sir.
So you can take it 6.67, you can take it 6.7, you can sometimes take it as 6.6 also, just to improve your calculation. So that you are getting a good calculation, you can take it as 6.6 also. Right?
Yes, sir.
So here the calculations are very important. You should know how to perform such big calculations. So if you divide this 6.7 by 4, you will be getting divided, and see you get 1.6 Okay, 1.67 into 100 can be written as 10 to the power 2, and this is 10 to the power minus 7. So you have 10 to the power minus 5 Newton. So this is the force between two objects. Okay, so is there anyone who has obtained the similar answer? Now I shall check from the section, chat section, if anyone is there who has obtained the same answer. Siddharth has obtained 1.67 into 10 to the power minus 4. So just a small calculation. Siddharth, now you are able to get where you were wrong?
Yes, sir.
Okay. Then Harini,
Yes, sir.
you got your correct, got your point where you were correct?
Yes, sir.
Okay. And I think Oro Smith has got the correct answer. Yeah, Oro Smith, you have got the same answer? Yes,
Yes.
Oro Smith has got the same answer, 1.6 into 10 to the power minus 5. Chavan Kaushik, your answer was incorrect. Are you able to get it?
Yes, sir. I did some silly mistakes there.
Okay. So that is why we are doing this question, so that we are able to remove our calculation mistakes. We should not be doing such silly things of calculation mistakes. Okay. So let's see the next thing. I give you the next question. You have to, I'm giving you a next question which you will be solving. Okay. So your question is, what is the force of gravitation between Earth and Sun? This is still a big calculation. I will show you by solving how we can perform such big calculation to a very small. Okay. But you will try it out first. Okay. So what is the force between Sun and the Earth? Okay. So what data you are given? Given that mass of Earth is 6 into 10 to the power 24. And mass of Earth, mass of Sun is, okay, what is the mass of Sun?
Wait, sir. I'll search it up. Sir, 1.9891 times 10 to the 30th power kilograms.
Okay, mass of Sun is 2 into 10 to the power 30.
Page.
Two into 10 to the power 30 kilogram. Okay. Also, the distance between them, Sun and Earth, Sun and Earth, between Sun and Earth is 1.5 . into 10 to the power 15 meter. Okay, so now I think you can do your calculations. Okay, so take it as your homework or try doing it in your homework. In the next class, I will explain this answer to you all.
Yes. Thank you so much.
Okay, I will be updating this in your homework section and even in your lecture section.
Wait, sir, I'm doing it right now. Can you wait for like 3 minutes? I'll be done.
I have a class.
No, sir, but this class ends at 6:50, right?
Yeah.
Yeah. Can you wait for 1 second? No.
Okay. Okay, fine. Do this.
Sir, I got 3.52 times 10 to the power 22. That's wrong.
Okay. Okay, so I'm noting your answer. What is the answer you are getting here?
3.52 times 10 to the power 22
Okay.
newtons.
Okay, fine. I'll be evaluating it in the next class. Okay. Bye,
Okay,
everyone.
sir. Bye, sir.
Okay, bye.
Bye, sir.